More than a question, and maybe just some clarifications. I work in quantum mechanics, and most of my publications are in quantum entanglement. I've worked in it for over 30 years. Maybe it just help to clarify what the questions are, and then you'll probably, it demythicides. There's a Greek myth around quantum computing. In fact, the question isn't ethical implications of quantum technologies, it's of computer technologies, if you like. Very quick lesson. Classically, if you can imagine, just a model, classical physics, take the solar system, had the sun and planets. We can write down a precise equation, or within the context of Newtonian mechanics, that allows you to basically, once you make an observation of where the planet is, you can predict for the next thousands of years where that planet will be forever, right? There's a very clear deterministic equation relating planetary motion around the sun. In fact, it's Kepler's law. First law of motion is that all planets move around the sun or a star, but the sun is one of the foci of an ellipse. So if you know the geometry of ellipse, you got it under control, provided you have a starting point. If I say the Earth is on an ellipse, and you say, yeah, but where's the start? Well, we need an observation, right? There's your telescopes coming in. With quantum mechanics, it changed the way. Supposing you were a physicist at the turn of the 20th century, you're asking the exact same question about the atom. You're seeing the atom as a microcosm of the solar system. So you should be able to model the electron now by electric charge, which is analogous to gravitational pull, with the same type of equations. Catch. The moment, well, where are we starting from? The moment you try to observe in quantum mechanics, now we can take our telescopes and look. The light bouncing off the planet doesn't change anything. But light bouncing off an electron or a proton is like slamming two cars into each other. Boom, they're scattered, pieces fly out and they fly all over the place. You've lost control. So you can no longer ask the classical question. You could say, well, it's a really classical, but if I don't interfere, we leave that open for the moment. But the point is, from a physicist's point of view, you can't get away with the question. Every attempt to look at hydrogen atoms or helium atoms, you can't look at them in the same way, okay? So what we do know, change the question. Spectra, when they heat up hydrogen or helium or whatever, you notice spectral lines come out, and they're jumps, which was not expected, for example. Would not have been expected at all. Look into the history of quantum, but essentially that would not have been foreseen at all in classical theory. Where would you expect more like the rainbow? You've seen the rainbow is light diffuse. It goes from red to violet continuously. If you run a spectrum of a vibrating atom, you get bands. And that's called the quantum leap. Okay, first thing. Second thing, since you can't observe the phenomena, we can observe something, the spectra. We can work out a probability theory of how the spectral lines are working, or where the atom might be, or the electron might be in terms of probability distributions. And that's where quantum mechanics comes in. The famous Schrödinger equation, or the Dirac equation, solve for what's called eigenvectors, eigenvalues, pick out stability states, which allow you to, if you like, assign probabilities to different levels of energy and angular momentum. But they're probabilities. Okay, first problem. Quantum computing. How do you so that's something to do with computers. Computers come in independently. How do you introduce probability into a computer? Now that's the question. Because all the problems up to now, basically with computers, are classical, deterministic, very, very fast. No doubt. As I said, in 1997, game of chess, Deep Blue did 2 million calculations per second. I mean, think about it. Nowadays, I'm sure it's in the billions, right? How do you introduce probability structures? It seemed, so there was a thing called a pseudo random generator. An algorithm is invented to produce numbers. There's actually various algorithms. And the real question is, they seem to produce random numbers. Well, A, are they really random? We're never really sure. B, the algorithm repeats the same numbers all the time. So somebody steps back and says, well, if they're the same numbers all the time, they're no longer really random. Okay? So you got a problem. So you introduce a seed. We're getting to...
Sorry. In a sense, you illustrate everything what you say is right, by the way. Actually, it's really informative. But you illustrate,
well, again,
in part, also a phenomenon which, in ethics, kind of derails the discussion on the impact of quantum technologies on society.
Well, it's
because
the philosophy.
If you present it like this, then your thoughts are going, okay, it's about physics, it's about worldviews, whereas it's not. I give you an example, and then I'll shut down, by the way. I give you an example. I had a question about what can you do with quantum sensors, quantum computing, quantum internet in a harbor, a port, naval port. What happens with if I, with a quantum sensor, look underwater and see what is glued to the hulls of ships? I didn't answer that question myself. I went to a harbor and started to talk with the security people looking at the monitors, checking the harbor site, what would happen. And they gave me an answer, which was really interesting, about what the impact on the harbor would be of that technology. And they more or less said, don't say anything about quantum because it distracts. We want to know what functionality the technology has, and we focus on that.
Well, that way I apologize. I'm not trying to, but I'm a trained mathematician. I want to know, but the question is that how do you introduce probability structure intrinsic to the computer? And at the end, quantum entanglement does it for you without elaborating how I won't elaborate how entanglement works. But there is an intrinsic probability structure in the hardware. If you could do it with the software, we'd have done it. It's a lot easier to write software, but you can't. So you do a hardware, but the problem is to do with the hardware, you have to cool down, you need particles to entangle, they pair off. So it occurs naturally when you get close to absolute zero, and that's why everything is so hard to control, because it's cold near zero, and you've got all what's called the background noise, and so it's very hard to stabilize. But here's the advantage, and to your question. Where you in the classically want to put random probabilities in, putting seeds in, they'll ask you what's your seed, it's taken seconds. This has been done in milliseconds, in nanoseconds, and it's doing billions of calculations for your one calculation that you would have done. I mean, the rapidity is incredible. And it opens up a whole range of problems that we couldn't treat before, where it would have taken probably the time of the universe to solve a problem. Now you can do it in a rapidity you wouldn't have expected. That's, in essence, what's going on, okay?
Thank you.
Please. So you mentioned that it might be hard to do responsible research and innovation in this field, but I think I have an interesting counterexample, or a semi-counterexample. I did a red teaming exercise about quantum biology recently. Basically, a funder was about to fund a project in investigating are quantum interactions playing a big role in biology, like some people have been arguing? And this was kind of developing a tool for actually finding that on a large scale. But then we asked a really good question. In 30 years' time, suppose we really regret ever having funded this field. What has gone wrong? So me and a friend got hired to kind of put on our evil genius hats and come up with the worst thing ever. And it's an interesting case because we don't know whether quantum biology is really a thing beyond a few things in photosynthesis of a magnetic reception in retinas of some birds. But we worked out a bit of a framework about when can quantum interactions in biology matter in the large, where they have ethical implications. And then we used a bit of a scenario planning method to figure out a few scenarios where assuming biology really uses it, and we can manipulate it like it looks possible using weak magnetic fields, we could do evil stuff. So we have been thinking about crashing photosynthesis and winning elections by using malware manipulating enzymes in people's bodies. Lots of stuff that conspiracy theories really would love. And would this actually work? Nobody knows. It doesn't matter, because the most interesting thing was we could then compare this to actual poisons, guns, and bombs and show this is not terribly worse than that. And in fact, all the dangers we can get out of this particular quantum biology threat model is it's stealthy. But it's stealthy because by assumption it uses weak magnetic fields, but in order to learn how to do this, you need detectors for weak magnetic fields. Everybody will want detectors for weak magnetic fields, and quantum technologies are good at detecting weak magnetic fields. So our recommendation to the funder was, please go ahead and give them a lot of money, but also make sure that we develop and push for more of these detectors. That means the bad sides of this technology are unlikely to happen. So I think this is an example of how one can take not just a technology that doesn't exist yet, but even a scientific question that doesn't exist yet, whether biology is actually making use of it or not, and actually work out things and even tell somewhat what the stakeholders might be. So I'm just curious to think about how are you thinking about threat models this way, because that might actually be a useful way, both for engaging with people, but also doing some useful RRI.
Yeah, I mean, like, maybe I can start and then like very quickly. So, I mean, as Peter said, it's hard to do RRI, but we have been doing it for quite a bit of time. So like next week we are organizing the 6th of the Responsible Quantum Technologies workshop in Karlsruhe. And we also did quite a bit of scenario analysis, like future studies work, and we even tried to just I don't think we did threat analysis or threat modeling, but basically the vanilla level of future studies stuff. And actually, something that we found was if you really push quantum technologies into the future in terms of the scenario planning, and you look at consensus models, it is quite boring. The technologies become boring. It's just normal, mundane. It's like computers. And then, this enigma element, this myth, it just disappears. And actually then you can start thinking about them more in a more sane manner, not something that is magical, not something that is to be hyped, but, okay, this is something that is coming in, 20, 30 years. It will have this and that and that and that, capabilities. So let's start working on that. So in that, I really like your example. And I think more and more of, this kind of studies needs to be, performed.
Yes, so you're right.
Yeah, you're right.
We can do already lots of things. So, for instance, in that harbor, I was exploring what if this design would be possible. What would happen? What would be the impact? And I gave a good answer. But it is not responsible research innovation in the standard sense that you say, I'm going to develop a drone for supporting conferences. So something is hovering around. Let's explore with stakeholders, what you think about that, and then we can make a little movie with hoovering. That is responsible research innovation, and you start adjusting the design. We're absolutely not in that phase, but we can do lots of other things, and great.
So, hi, thank you very much for the talk. I think I would go back to quantum computers and ask a question. I mean, I think you just mentioned it some kind of way. So do you think there's a need for a different ethical approach? Like, is there a need for a different ethical approach in quantum computing? Because it kind of differs fundamentally from classical computing, ? Just when you think of the term entanglement, superposition, blah, blah, blah. But think about traceability. It differs very much. I mean, you can compare it to the case of AI, but we have traceability, which is like the problem of the superposition, and we can't really reconstruct how it works because of quantum mechanics. I mean, we have quantum tomography. So the question would be, what is your take on that? And the second question would be, because you talked about social imaginaries, and there's a very nice book, it's Quantum Unspeakables, I think it's 1 and 2. And they talk about basically the ambiguity of the terms. So what is your take on that? Question to all of you. I mean, I would have more questions, but I think that's enough.
Well, I can start with the first question. Your first question was about basically, do we need new ethical approaches to quantum, to the ethics, in the ethics of quantum technologies? My answer is, I don't know, actually, because on the one hand, claiming that there is something really new in this technology would have, on the one hand, good ethical consequences, because it would, at least it would raise attention to these technologies. But on the other hand, a bad ethical consequence would be basically mystify these technologies, saying that, okay, we need something entirely new. On the other hand, saying that, okay, there is nothing special here could have bad ethical consequences, because it could also be a sort of complacency or lack of concerns. So we don't care about these technologies, we just need to apply, I don't know, AI ethics to these kind of technologies. So basically we can take the 5 principles by Luciano Floridi mentioned, they were mentioned this morning, and we just apply them, it's fine. On the other hand, saying that there is nothing special in these technologies can also have good ethical consequences, because it avoids the mystification of this technology, and it can give us a more practical and realistic approach, which is the right one when we have to apply, when we think about responsible innovation. So to answer your question, I don't know. We were not ready. We are not yet ready for this, for a proper ethical investigation. We have to prepare the ground by developing education, communication, which is connected to what we were talking about with the previous questions. So. That's it.
Yeah, maybe one thing I can say is, like, I agree with Luca that we don't know in general, but also there are quite a bit of studies trying to learn this, you know, because let's say you have quantum machine learning algorithms. What is actually different compared to classical machine learning algorithms, and which machinery we developed for classical machine learning algorithms, things like, you know, explainability or, you know, fairness, trustworthiness, like how does it translate into quantum machine learning algorithms? Like, can we just automatically apply all these principles? Do they need, you know, new technical embeddings? Like, there needs to be a different way to embed, I don't know, accountability into a quantum machine learning device. These are open research questions, and I think people are quite, you know, working on this. I mean, another example is on quantum sensing. So, I mean, as far as I know, until COVID, like infrared surveillance, it wasn't really legal. But with COVID, we have infrared surveillance everywhere. What about the rest of the spectrum? Like, are we okay with, I don't know, brainwave surveillance? Are we okay with other kind of surveillance? Because previously it wasn't a real question because the technical capabilities were not there, and now, since it is, you know, becoming more and more, let's say, we are capable of it, then we can start discussing, okay, do we want this, do we don't want this, is it something new, like, yeah, so.
Just a follow-up. I mean, claiming that there is nothing new from an ethical point of view doesn't mean that we cannot think about possible ethical cases, possible ethical scenarios. For example, we could mention a case me and Pieter, we worked on, the connecting quantum computers. which is a really good case from a political point of view also, because what happens if you know that quantum computers can make absolutely secure communication possible. So what happens if France has a quantum computer, the Netherlands have another quantum computer, Italy has another quantum computer? Is it morally okay? Is it strategically okay to connect the quantum computers? Does this create some diplomatic problems, diplomatic issues also? Because maybe I have some plans I don't want France to know about. So this is already a case of a political problem posed by this kind of technologies, a strategical problem.
Any take on tomography or not? We can discuss it later, but I think I would be just interested.
What do you mean by tomography? Is it just state tomography?
There's quantum tomography, so you can basically reconstruct, or it should be possible to reconstruct the calculation, like how the process of calculation works, which should not be possible in quantum mechanics. Within a quantum, okay, you don't know.
No,
we can discuss it later.
Discuss
I think that's.
Yeah. But, yes, I would say that, let's say, the probability and explainability is not such a big issue. It is an issue in AI anyway, and in neural networks and so on. Does quantum add stuff? Yeah, I don't think so. So if you want to have a MRI scan with quantum computer set of sensors, that is possible, but it will never be used with diagnosis of tumors with a probability. So yeah, well, okay, we identified the tumor, but with 30% chance. Then the technology is not yet ready. And then you send it back to the factory and say, well, why don't you come up with an MRI scan which with 100% or 99% gives a diagnosis? So the engineering, on paper, you really could have funny quantum phenomena in the outcomes. From an engineering point of view, would try to avoid it as soon as possible. So that's, I think, many of those questions will evaporate if you design well.
Yeah, we can discuss later on.
I came here with zero idea on quantum technology, and now at least I understand a bit, or I found the panel very enlightening. And I guess the question, question together, is about this translation capacity. You mentioned about the harbor experience, or even your dialogues with policymakers, and that you had to explain in seconds the impact, both good and bad, or the functionality of this technology. And I think all the technologies, biology, genetics, we need that capacity or that talent in the other science as well if we want to make a social debate or public engagement. And then the people working on technology need public input, but if they don't know how to translate and explain what they are doing to the public, they won't get any useful input, right? Dialogue will just never happen. So can you just walk me through your mental process? How do you actually translate your complex field in a way that people can understand and relate and engage in a dialogue? And how can we use that maybe in other technological fields? Thank you.
Very nice question. So I also did philosophy of design, and design in RT design. And what these people do is they listen like crazy. They walk around and they look, they observe, and then they collect data. So in terms of communication, they're not sending, but they are receiving. My experience was, a little root in my development, was the first time I went to The Hague. The Hague is the seat of the government in Holland. I got 20, 30 high-level policymakers in the room. And I realized they don't want to talk with each other because they're competing. A second, wow, quantum is really interesting because why on earth are these here? The construct, the organization we did was we brought a physicist from an engineering department. Okay, 20 minutes explaining what it is, and then you can come up with your questions. Well, what happened was that after 30 minutes, the whole room was brain deaf. They said, oh yeah, sure. Okay, and they were on their phones because they had other things to do. The next thing was to say, okay, first of all, we sent, we have the physicist in the room, but typically he, doesn't say anything. We just say, look, we're here for quantum technologies. What have you learned about it already? And these 30 policymakers had already studied it. They had already downloaded Wikipedia or whatever. They had questions. So the first step is to just say, okay, what do you have as a question? And then all of a sudden the information came. So can we use quantum technologies to communicate faster than light? I'll ask the physicist. Sorry, we won't do that. Can we use, also a Dutch example, can we do sensors everywhere in the big rivers which come from Germany and have online analysis of if there's pollution in it? We always, the Germans put the pollution into the Dutch rivers, and we want to know that in advance. And they said, yeah, never thought about that application. They thought about that application. So they told us, so I was in learning mode. Of course, I could tell, well, sorry, that quantum computer doesn't exist yet, but in 5 years' time, you might do that. But reversing the table and start listening, and of course, informing, stepping in if something odd was being said, that's the way to explore the impact of a new technology. Don't take the other as a layperson, take the other as an expert. They already have studied the material. Okay, let me stop there.
Would you like to add something?
No, I don't have anything to say.
Yeah, please. Yeah, please.
Well, the title of this panel is Ethical Implications of Quantum Technologies. So my question is, what is specific in quantum technologies in comparison to other technologies when ethics is concerned? So I haven't understood that really. Okay, you mentioned whether if the Netherlands and Italy, you gave that example, have a quantum computer, should they share? Or what you mentioned, the enrollment of students. Should students from, you mentioned Asia, but we can say, frame it differently. Should students from authoritarian countries or whether Western democracies, liberal democracies, traditional ones, can become autocratic and so on. So opens questions in the field of political theory, political philosophy, ethics in that field. But apart from that, what you suggested, I haven't discovered anything that is specific in the ethical implications of quantum technologies vis-a-vis other technologies. Could you be more specific about that?
Maybe I can start with that and just leave to you later. So as I said, so there are mainly three approaches to studying this ethical implications of this technology issue. So like you have the normative approach, which like okay, let's look at, as Luca said, let's look at what is special. So try to identify if there's normatively something different needed compared to AI, compared to nano, compared to bioethics, compared to general technology ethics. The second is about pragmatic. So as you mentioned, connecting different computers and basically looking at applications and then trying to identify whether there are any ethical implications of these applications. And the third is, of course, like with critical assessments about the contexts and the situation and geopolitics and how it ties to other fields. From a pragmatic perspective, like on the second approach, I can give a few examples. Maybe they will be, good in that sense for you. The first is about quantum communications. So basically, there is quite a bit of active discussions about how should civilian populations have access to absolute private and secure communications. So before quantum communications, or less discussions on QKD, the debate was usually about cybersecurity, and with this, how to say this, like there's extreme cases. So basically, the state wants the power to be able to decrypt your encrypted communications. So everybody has access to encrypted communication capabilities, but if the state wants to, it can interfere and decrypt specifically your communication. With QKD, this becomes impossible if it is implemented properly. So the question now becomes, should it be implemented properly, or should there be intentional backdoors into these devices so that with court orders the state will be able to intervene or not? So that's one thing. The second specific thing about quantum sensors is this, basically surveillance. So if you have access to a lot of other spectra in the full spectrum, how much of it is allowed to be surveilled for public spaces, for example? Like, should there be, or is it permissible to have brainwave surveillance in public spaces to identify, high stress individuals? It's an actual question. At some point we will need to regulate this, and with certain type of quantum sensors, this becomes a practical question rather than a theoretical or a normative, let's say, basically, just science fiction kind of a discussion. I would say that with quantum technologies, with all emerging technologies, this is, at least from a technology assessment perspective, this is the most relevant ethical implications discussion. The novel capabilities that comes, even if potentially, with these technologies, kind of pushes us to discuss parts of how we organize our societies, and what we want, what we don't want, what is permissible, what is not permissible. So that's basically how, at least me and in the technology assessment field, we kind of try to put in the ethics into the debate here. But there are, of course, a lot of, as I said, there's critical, normative, different kind of approaches, and I'm a very, since I come from physics, I'm a very pragmatic kind of, perspective on this. I mean, if you ask Armin Grunwald, I think he has a different perspective, and he's the head of TA in general, so I wouldn't say this is the TA perspective, but more of a pragmatic approach perspective to the ethical implications of quantum. But, do you have...
Absolutely, I completely agree with what you said. Well, as I said beforehand, there is no need of having a specific, completely new ethical problems in order to consider a technology morally relevant. It also depends on the people involved, in the interaction with other forms, with other kind of technologies. It depends on the context, it depends on the social acceptance of the technology, the process of trust. We mentioned trust beforehand. So there are so many variables that it's really complicated to see if a specific kind of technology raises completely new ethical problems or needs completely new ethical approaches.
Maybe I disagree. So I don't think that the technical functionalities which quantum will bring are really bringing the novelty. So there will be super surveillance, but yeah, in the DDR, former Eastern Europe, Germany, you had also huge surveillance. We don't need quantum sensors for that. Secret communication, Do we need quantum? No, darknet already gives you that. So lots of questions which are raising within the arena of quantum tech are ones which at least you can approach with existing technology. Of cases of existing technology. If there is one phenomena I would place my bets on as saying, okay, in 20 years' time, if we reconvene and talk about, okay, what was the impact of the ethics of quantum technologies, I would say that was the first clean-cut case where ethics of technology had to deal with geopolitics. So, no open science. Even big tech companies are about to get cut up because we in Europe don't want to anymore use Microsoft so much. IBM has the biggest quantum computer in the world right now, but it's everywhere. Washington, Beijing, and Brussels don't want to buy that quantum computer at a firm which also sells it to the other. So lots of new phenomena are kicking in. And that causes lots of ethical considerations, and I guess lots of new theory will emerge or application will emerge. It has not so much to do with entanglement, decoherence, or superposition. So that would be my answer. That's the specificity. But I disagree probably with the others.
No, I mean, it's really interesting because this means that for the first time, maybe we first need to better understand the geopolitical issues connected to this technology in order to better understand the ethical aspect of this technology. And this means that we need much more investigations in order to be able to understand these ethical issues.
So actually we can conclude then that the ethical implications, if we follow what Pieter says, and how I understood it as well, that the ethical implications of quantum technologies are implications in the field of political philosophy.
Sure. And have an impact of about 50 billion euros. And so there will be lots of new technology coming. And I'm really happy if we can actually deal with ethical issues with existing knowledge. The more normal it is, the better, in a sense.
What Zeki said is more something that is direct to the future. So currently, what is specific in these ethical implications are very specific implications in political philosophy. Okay.
Yeah, I mean, I would also agree there as well because, I mean, think about digital divide. Like all these discussions about digital divide, it happened in a different era. So like we approached that issue differently compared to how we are discussing the issue of, I don't know, this quantum divide now. So you're definitely right, but at least from what we do for this the ministry and then the parliament, so it's not necessarily only geopolitics. So we cannot just go to the German parliament and tell them, okay, you wanted a report on the military use case of quantum technologies, and to be able to do technical assessment on them. It's all geopolitics. No, but we also have to identify, okay, what are the novel capabilities that comes from, where are the legal gaps coming from it, and what are the implications or the moral dimensions of this. That's why I think like the pragmatic approach also kind of plays a role here.
Okay, thank you.
So would you agree then it's the volume of information that's going to come so much, it'll be so much, but we just don't know the consequences of how people are going to use it. A bit like the large language models bring ethical situations with who uses large language, just how your students are using it. It's just quantum computing has the capacity to bring solve many problems very quickly, and we're overwhelmed with data. That's at the end we don't have to control it.
No, I mean, like, Pieter or Luca, would you like to take a shot at this?
I think it's more surveillance, which is the interesting one. And so that will generate so much information or data. Yeah, together with a quantum computer, if you can analyze that real-time information, real-time, yeah, that would open up lots of new functionalities. So in that sense, yes.
Security, how would you code? It'll crack it much quicker than you trying to.
Yeah. No, so that's true. Eh? So the biggest impact actually right now is in a domain where you would never expect it, namely how to get big organizations aligned in making an adjustment in their encryption. The short version is quantum computers can decrypt your digital communication, probably in 20 years' time. We don't want to wait for that to happen. How about changing our encryption right now? And then, oops, that means that 5,000 organizations in a country like Holland have to simultaneously adjust their encryption and certification, and well, that opened an enormous can of worms. Has nothing to do with quantum, but more about how can you bring countries aligned in actions.
It includes your understanding of quantum, I think, fully, but it's the quantum that's allowing you to do it very quickly.
Sure.
That's the point. It's the speed which is going to be that, and we're not ready for it, probably. The overwhelming ability to crack problems that we can think are doable.
Any final questions or comments? Stephen? Yeah, if not, let's thank to our panelists.